we will be drunk and all of our thumbs went up in the air. Sunken in the wind, listen to the thunder rolling over and over. We down, we're getting on fire, we're raising up higher. The bottle is up, we're over the top, it's time to get dialed. The time of the night.
Good day, viewers all over the world. My name is Engineer Yemi Opreshade, an engineer turned teacher of about 3 decades of teaching experience, cutting across nursery, primary, junior high school, senior high school, advanced study, and even down to the university. So we have had a whole lot of experiences communicating STEM with students of different tribe, of different age, of different thinking, of different intelligence. Today we are looking at part 3 of the topic on Pythagoras theorem. Today we are looking at the real life application. Now this is beyond the junior high school two students. It now goes metamorphosed into students that are preparing for either senior high school, WAEC, NECO, JAM, SAT, SAT, IGCSE, any aspect of examination that has to do with mathematics, you've got to find the areas of application of Pythagoras theorem. Importantly, students that are preparing for one competition, whether at junior secondary school level or senior secondary school level, preparing for maybe a competition like Cowbell, Olympiad, SAT, and so on and so forth, you will find this topic very, very important, especially the areas of application. So it has gotten a whole lot of diversity in application, in surveying, in bearing, in trigonometry, in the measuration of plane shapes, kite, rhombus, triangle, rectangle. You will surely find the need for you to apply Pythagoras theorem. And so it's a real serious work, a real business for you to be literate in Pythagoras theorem. I have some questions on the board. I'll come back to that. They also have quite some questions here. I have about 6 questions here. I'm not going to write the question on the board. I'm going to read it out, so you have to be attentive. I believe you know that in STEM communication, this is not listening to music. This is not listening to a man of God preaching. This has to do with knowledge. You have to hold your Bible. You have to be with your notes. And you have to be up and doing. You are listening, you are looking, and you are writing. Those 3 parts of your body must be active at the same time. And so I'm going to test that out with this particular video production, because I'm not going to write a question. I will read the question out. I expect to write it down, then I solve it. So we are looking at part 3 of Pythagoras theorem, which has to do with the real life world application. Number 1, take the diagonals. The diagonals of a rhombus. The diagonals. I will tell you what is meant by diagonal. The diagonals of a rhombus. A rhombus is like a diamond, a shape that is like a diamond, are of length 80 centimeter and 60 centimeter. The diagonals of a rhombus are of length 80 centimeter and what? 60 centimeter. Calculate its perimeter. Calculate its perimeter. I take it again. The diagonals of a rhombus are of length 80 centimeter and 60 centimeter. You put a full stop. Calculate its perimeter. You must learn how to write in shorthand form. Hello? When I say calculate, you just write CAL. Okay? When I say perimeter, you just write peri. Is that clear? You don't need to write it in full. Is that clear? You must got to know how to take notes. Okay, now the question here is a rhombus. A rhombus is a plane shape. So if they expected you to know how to draw a rhombus, hello, look at this. It looks like a diamond. It's also called a diamond. Just like a square, all the sides are equal. They are the same. The length are the same. We call it slant height. you can see that the length looks slanty. They are the same. Is that clear? A rhombus resembles a square because all the sides are equal. The only difference is that the angles are not equal. Opposite angles are what? Equal. This angle equals this angle, and this equals this angle. Okay? We are not treating properties of a rhombus, but you need the property to be able to solve this problem. Okay? Now, they said diagonals. Hello? These are the diagonals. This vertex join with this, and this join with this. Now, one of the properties of a rhombus is that the diagonals, okay, when they meet at 90 what? Degree. When they intersect, they meet at 90. So this is 90, this is 90, this is 90, this is 90. Is that clear? Then the diagonals also bisect each other equally. If this is 100, this will be 50, 50. If this is 60, this will be 30, 30. Is that clear? They bisect. That means they divide into two equal parts. In this question, you can see clearly that one is longer than the other. Is that also? So these are the diagonals. These are diagonals. This and this. One is 80, the other one is 60. The longer one is 80. Half of 80 is 40, right? This is 40, 40. The shorter one is 60. This will be 30, 30. Do you see that? Now, if you look at this, this is 40. If you look at this, these diagonals divide this rhombus into 4 equal right angle triangle. Look at this, like this, like this. If you take a knife and slice it along the diagonals, this is what you have, like this, then like this. Each of these are the same. Each of them has 90 degrees. Is that clear? Okay. Do you understand? So you can see. So it means that one of them can represent all these other four. So you just pick one like this. This is 40 centimeter. This is 30 centimeters. Is that also? Then this is the side. Now all the sides are equal. All the sides of a rhombus are equal. Okay? So that means you need to find this side. Do you understand now? Can you see that it has gone back to right hand wall triangle? That is why it is applicable to Pythagoras theorem. So if you look at this now, using Pythagoras theorem, PT, which one is the hypotenuse side? So L squared will be equal to this 40 squared plus 30 squared, right? L squared is now 40 squared means 40 times 40 plus 30 squared is 30 times 30. So L squared now becomes 40 times 40. 4 times 4 is 16. You just add those two zeros to it. Plus 3 times 3, 9. Those two zeros you add to it. Now L squared becomes 1,600 plus 900. I hope you know how to add. That will give you 2,500. Okay? To find L now, what do? We find the square root of both sides. 2,500. Okay? The square root of L squared is L. Now, the square root of this, you can break this up into 2,500. You can break it into 25 times 100. It's the same thing. Then, you can separate it like this. Square root of 25 times square root of 100. Applying laws of indices. If you have 2 times joined by multiplication inside square root symbol, you are allowed to separate it. So L now become, what is square root of 25? 5. Times, what is the square root of 100? 10. So our L is now 5 times 10, which is 50 centimeters. Now the question says, calculate its perimeter. You will now calculate the perimeter like this. Can I claim this now? Let me just come here. You now find it. You now say therefore perimeter. The perimeter means, hello, all the length, all the boundary length of this rhombus, that was called perimeter. How many L do you have there that are equal? 4. L plus L plus L plus L. That will give you 4 L. So this will be 4 times L is 50. Can you see that? 4 times 50. And if you multiply 4 by 50, that will give you 200 centimeters. That is one area of application of what? Pythagoras what? Theorem. You have used to find the perimeter of this whole rhombus. Can you appreciate that? Look at it. Look at it. Look at it. Look at where we apply Pythagoras theorem based on this right angle triangle, and then see our final result. Alright, question number 2. I want to clean this. I think I'm free to do so. Okay. I want to clean this. I want to clean this. I want to clean this. Okay, now, question number 2. I want to read it. Hope you are with your pen. Hold your pen, right. Now, look at this. A conical glass has base diameter. A conical, a cone. That is a cone. That's a solid shape, okay? Which is also called a pyramid. A good example of a pyramid. A conical, a cone. Now, a conical glass has base diameter of length 80 millimeter and of length 80 millimeter and slant height of 50 millimeter. Calculate. Roman numerals 1, its vertical height. Roman numerals 2, its capacity. Roman numerals 3, its curved surface area. Roman numerals 4, its total surface area if it is sealed with cellophane paper. I take it again. A conical glass, conical, C-O-N-I-C-A-L, a conical glass has base diameter, the base diameter of length 80 millimeter, okay, and slant height of 50 millimeter. Slant height. Slant means inclined. A side that is not standing vertical is slanting, okay? Calculate. Roman numerals 1, its vertical height. 2, its capacity. 3, its curved surface area. Then 4, its total surface area if the open part of the cone is sealed up with a paper. Now look here. Sorry about that. Look here. Now, this question is talking about a cone. You have to draw a cone first. That's a cone. A cone has diameter. This is the diameter, and half of diameter is radius. That's the cone. This is the vertical height, the one that is standing erect. These are the slant height, and this is the radius. The radius is half of diameter. So if you are given diameter G, you can calculate the radius as half of it. Is that also? In this question now, we are given the diameter to be 80 millimeter. So half of 80 give you the radius from here to here. Give you the radius. That's half of 80, that will be 40 millimeter. Okay, another information given to us then. Okay, they said the slant height. This side is 50 millimeter. So that means this place is also 50 millimeter because these are the slant heights. From this, you can see clearly that you can bring out a right angle or triangle. Can you see it? Can you see it? The height, the radius, the slant height. Even from a cone. Is that clear? That is where Pythagoras theorem is applicable. Do you see that? Can you see right angle triangle there? Because this vertical height and this radius, they meet at angle 90 what? You need to know that. That's very important. This vertical height of a cone and this radius, they meet at 90 degrees. So that makes this law to be applicable. So what are the things that they want us to do? Number 1, they want us to find the vertical height. That is the h. We are looking for this height. Number 2, we are looking for the capacity. Capacity means volume. Volume of the cone. Number 3, they have to calculate the curved surface area of the cone. Then number 4, they want us to find the total surface area of the cone. So all these things borders on you knowing the height. Is that clear? So are you here? Are you listening? So from Pythagoras theorem now, PT, from Pythagoras theorem, we can see that the slant height is the hypotenuse. Hello? This side opposite the 90 degrees. Is it not the hypotenuse? So that means L squared equals to the sum of the square of the other two sides. That is a squared plus r squared. So with this now, our L is 50. The slant height is 50 squared. Our h, that's what we're looking for. Then our radius is 40 squared. 50 squared means 50 times 50. That will give you 2,500. This is h squared plus 40 squared means 40 times 40. That will be 1,600. I will take this to the other side because what I'm looking for is h now. This will become 2,500 minus 1,600 equals to h squared. Okay? If you minus this, if you subtract this, what you have will be 900 equals to h squared. We are looking for h now. You find the square root of both sides. Square root of h squared. Now this 900 can be written as 9 times 100. That's 900. So that it will be easy for us to find the square root. Then square root of h squared. What is the square root of 9? 3 times. What is the square root of 100? 10 equals to, what is the square root of h squared? H. So our h now is 3 times 10, 30 millimeters. So that is the vertical height they were asking you. Then with this now, you can begin to answer the remaining question. Can I clean this? Can I clean this side? Can I clean this side? I can clean this side now, okay? Now, they said you should calculate this is Roman numerals 1, the height, the vertical height. The second part is they said you find the capacity. Capacity means the volume. The volume of a cone is this 1/3 pi r squared what? H. What's the formula for capacity of a cone? 1/3 pi r what? You just substitute down the 1/3. Pi is a constant. They will give you as 22/7. The radius is what? Look at the radius, 40 squared. 40 times 40, that is 1,600. Okay? Is that clear? Times the height. What is the height? We have gotten the height to be 30 times 30. So you finish this up by cutting. Your answer will be something in millimeter cube. That is unit for capacity of volume. Then number what now? Number 3. They said you calculate the what? The curved surface area. The curve, the body of the cone, not the bottom circle. The body is called the curved surface what? Area. So the curved surface area of a cone has this formula, pi r l. Pi is 22/7. The radius is given to you 40. The slant height l is 50. Okay? Is that not? Then number 4. Total surface what? Area. Total now is, there are two parts to a cone. The bottom that is circling, look at it. This side and the body, the entire body. Is that clear? The entire body of the cone is the curved surface area. Then the open part is circle. That is the circle, area of circle. And you know that area of a circle is what? Pi r what? Pi r squared. Curved surface area, that one is pi r l. Do you understand? So if I ask you to calculate total surface area now, number 4, let me clean this. Let me clean this. Let me clean this. If I say to calculate the total surface area, what it means is that it is made up of the curved surface area plus that part of the cone that looks cyclic. Then that will be, this one is already pi r l. You see this one in your figure table is a formula. You are supposed to be familiar with them. Then area of the circle is pi r squared. So all the information that you need to calculate the total surface area are there for you to compute. Is that clear? So you can complete that. Thank you. Now let's go to another one. Let's go to another one that has to do with the application of Pythagoras what? Theorem. Okay. Then after that, I will explain I'll just take one more question because of our time. Then we'll try to see for students that will be joining us that are registering fully, especially for the SSC student, whom this aspect of Pythagoras theorem is very relevant to. Then I will need to, once we register and you have a link with us, and then we can send you some other questions, okay, that befit the status of those kind of external exam or competition that has to do with this, okay? Because we have limitation, you cannot just keep on solving. That is why there is need for you to get registered after listening to this kind of lecture. So let me go to one more example. Are you with your pen? One more example, then we try to call it. I will not try to explain this one so that you find it very easy to relate with. Okay? Take your pen. Right. An aircraft was piloted from a spot not, look at it, not 30 degrees east, right? Not 30 degrees east, write it that way. Not 30 degrees east, okay? To cover a distance of 40 kilometers. To cover a distance of 40 kilometers. Full stop. Are you following? It was then flew to a destination. It was then flew to a destination at, look at this, 300 degrees. 300 degrees. That's the bearing, that's the direction. After covering 30 kilometers. After covering 30 kilometers. Calculate the distance from the starting point. So this is a question that has to do with bearing. I told you the other time that the Pythagoras theorem is relevant to so many topics in mathematics. That is why, even though it is being introduced at junior secondary school too, it is relevant all through GSS 3, senior school 1, 2, 3, down to the university, because it's an important topic that cuts across other topics. Okay, now let's start now. Look here. An aircraft was piloted from a spot. Now look here. This has to do with bearing. I will just interpret this. At the end of the day, we are going to come up with something like a right angle triangle. But let's see how it is done. Now this is a compass. You have to draw the four cardinal points of a compass, which give you direction. Hello. This is north. This is south. This is east. And this is what? West. Now they said an aircraft was piloted from a spot. This place is the spot. Call it maybe something like maybe X now. That's the spot. So X is the starting spot. The starting spot. Okay? Do you understand that? So they said that an aircraft was piloted from this spot X, north 30 degrees east. Hello? North 30 degrees east. Can you see north and east? That means it moves like this. 30 degrees. Then it goes this way. Do you see that? This is 30. Each of this angle here is 90. So if this is 30, 90 minus 30, what will be this place? 60. Do you understand? You quickly write that one there. Then that is the first sentence. They say it covered a distance of what? I have to clean this. It covered a distance of 40 kilometers. So it moved after that bearing and moved 40 kilometers. Write 40 kilometers here. Then what happened? It was then flew. Hey, it got to this place. The same aircraft. When you get to this place, then that is the same direction. You have to draw another four cardinal point again, because that aircraft want to change direction. This is north, south, east, west. Hello? So from here now, it wants to change direction. At what angle? At 300. They told us it moved at 300 degrees. you start from the north. This 300 here is 0. 0, 90, 180, 270, and back to 360. So 300, look here, from here to here is 90, to here is 180, to this place is what? 270. And you are going to 300, it remains 30. So it's here, you just cut it here, a bit of 30, and then it moves like this. Do you see that? Do you see that? So from here to here is 30, and everything is what? 360. Angle at the point is 360. So if from here to here is 300, then this place will be 60, the remaining part. And each of these, I told you that each of these is 90, 90, 90. So that means if this is 60, this part here is 30. You understand that? Now, if you look at these two north-south line, they are parallel. North-south are parallel. Then this line becomes transversal. Then you have to apply your knowledge of trigonometry, plane geometry. If you have two lines parallel, this line is parallel with this line, then this line becomes a transversal line. It means that this angle here is alternate to this angle here. This is 30. This one here is alternate to this angle here. Let me clean this. This is 40 kilometers. So this angle is alternate to this angle here. That means this will also be 60. Can you see that? Hello? In this figure now, in this diagram, you can see that there is 90 here. 30 plus 60 is what? 990. Okay, this side, and then it covers a distance of what? 30 kilometers to this spot. Calculate the distance from the starting point. The starting point is this. See where the aeroplane is now, so you join this to this. Do you see that? This is the starting point. It moves like this, turn like this, and move like this. They say to calculate this distance, question mark. Now, if you bring out this triangle, look at it. This triangle, this one, and this. This is 30 plus 60. What angle is this? 90 degrees. Is that also? This place is 30 kilometers, and this is 40 kilometers. You are looking for this D, the distance. This place is the distance apart from the starting point. Do you see that? So what type of triangle is this? Right angle what? Triangle. So what are you going to use here to find this distance? Pythagoras what? So using Pythagoras theorem, which one is the hypotenuse side? D, you squared it, equals to the square, to the sum of the square of the other two sides. Okay? 30 squared plus what? 40 squared. Okay? So we have this squared being equals to this squared being equals to what? This is 30 times 30. What is this? 900 plus 40 times 40, 1600. So we have this squared now being equals to 2500. Okay? If you find the square root of both sides, you will get your D to be equal to 50 kilometers. And so that is the answer. Hello? If you find the square root of both sides, you will get it as this. Is that clear? So, it's like I'm still going to do part 4 of this topic because there are some areas I'm not even going to, which you need to be exposed to. You need to open your eyes to see certain things because all this external exam like Olympiad competition, cowbell competition, SSC, WAEC, NECO, NAPTEP, UTME, sometimes they can be very critical in the way they set their questions. So I promise you on this platform that we are still going to have Pythagoras theorem part 4. Is that clear? So that we can really go into this. But I believe you have understand this. Now let me explain to you some of the questions that I have here. I want to clean this up. Okay? I want to clean this. I'll just take time to shed light on this so that it will be easy. Especially because of the GSS students that are in our midst, that are following us, or that have registered with us, so that they will not have issue because this is a bit advanced. This is an advanced to the video 1 and 2 on this particular topic. Now let's look at this. I want to interpret this a little bit. Number 1, I've done something similar to that here, so I won't go into that. Now look at that number 2. An isosceles trapezium. There is a type of trapezium that is called isosceles. Have you heard of that before? Let me tell you what is meant by isosceles trapezium. You know that a trapezium alone has 4 sides. It can also be drawn like this. There are 2 sides that are not equal but are parallel. We call them A and B. And the gap between A and B is the vertical height, this. Now if you look at this, these sides are not equal. This one too, but they are parallel. That's why I showed this, they are parallel. That means they can never meet. But this is not equal to this. Just like this one, you can see, it's not equal to this. This is a trapezium. Now, there's a type of trapezium that is called isosceles. You know, from the word iso means equal. That means 2 sides are equal. Hello? This side is equal to this side. Whereas these 2 are parallel. You can see the application. Now, let me tell you one thing about this type of isosceles trapezium. If these 2 parallel sides are equal, then this figure will turn to a rectangle. Take note of that. If I should in any way make these 2 parallel sides equal in length, then it means that, and this one is equal to this, then I will end up having what? A rectangle. That looks like a puzzle for you to think about. Okay? We'll still come into all those stuff by the time we go to mensuration of plane shapes. So today is not the business for that. Now, this type of trapezium now is isosceles, where these 2 sides are equal. Now, if you look at this, if these are equal, then this is vertical. That's the gap. This is also vertical. That's the gap. You can see that if you are given the 2 parallel sides, A and B, to be 8 and 14. Look here. Look at the signs. Let me remove this A. We already know that these are A and B. If from here to here is 8, that's the shorter one. Definitely this one will be the longer one. That will be the 14. Now it means that from here to here is 8. It means that from here to here also will be 8. Now if you take away 8 from 14, what do you have? 6. Now since this place is equal to this place, so it means that this side must be equal to this place. So the total length is 14. I already have 8 here. This place and this place is 6, and they are equal also. Because this isosceles trapezium, you just divide this one by 2. That means this place will be what? 3 and what? 3. Are you following? Okay? That is that. Now, the total, if the gap is 40 centimeters. Okay, sorry, this is 4 centimeters. Okay, not 40 there. So if this is 4 centimeters, that's the gap. Then you can see that for me to find the perimeter, I need to know this length. Maybe this length is x and this is x, they are equal. The perimeter means I need to know this length plus this plus this plus this. The problem now is that we know this. You also know this 14. But here you can see that we can find our x if you bring out this right angle triangle. This is x, this is 4, and this is what? 3. Is that not so? So if you use Pythagoras theorem, you find your what? X. Once you know this x, you have known this, then you can now go ahead to find your perimeter. Is that clear? Okay, that is that. No, that's number 2. I've given you insight into that. I told you we are here for business, and it's about critical thinking. You apply, we give you knowledge, you apply it to us. Okay? Now, I want to clean it. With that insight, you should not have problem with this. I've told you the meaning of isosceles trapezium. Then the next one is, you are going to do it just a kite. Now, you need to know what a kite is. This is a kite. The 2 upper legs or sides are equal and shorter. Then the 2 lower ones are long. That's a kite. They are also equal. Now, this angle here, these are the two angles that are equal, opposite. These ones are never equal. They are not equal. This is the smallest. This one are the two largest ones, the two large angles, and they are opposite. Now, just like in rhombus, these are the diagonals. If you draw this diagonal, this and this, they meet at 90. They meet at 90, 90, 90. Now, you can see that this gives us up there two right angle triangle that are the same. Right angle triangle, smaller one. Then down here, we have two bigger right angle triangles that are also the same. So you need to understand this. Now, this one, this length here is equal to this length, the slant height. This one here is equal to this. That's attribute of a what? Of a kite. Now let's see what the question says. A kite has 8 centimeter and 12 centimeter as its short and long diagonals. This is the short diagonals, as you can see. This is the long one. Now, for this short one, it divides into two equal parts, the same. So if this is 8, the short one is 8, this will be 4, 4. But then for the longer one, you can see that even though it intersects here, this from here to here is shorter compared to from here to here. That's what they told you, that if after intersection, the longer is divided into ratio 8 to 3. These two are divided into this ratio 8 to 3a. You know, here you have to find the total ratio. Total ratio means a plus 3a, that is 4a. Then to get this one, maybe this one is m1 and this is m2. Okay, so you need to find your m1, which is for this ratio, the smaller ratio, the smaller length. Go for this smaller ratio. That would be a over 4a times, what is the length of this diagonal? They gave you to be 12 of 12. This a cancel this a, 4 here 1, 4 here is 3. So this side is this is 3. This is 4, 4. We are looking for this, we are looking for this. Then, if the total length is 12, you need to find m2. The ratio for that one will be 3a over total ratio 4a times 12. This a cancel this a, 4 here 1, 4 here is 3. 3 times 3 is 9. So this is 9, this is 9. Okay, this side is also 4, this side is also 4. This 4 is common to this 4 is common to this. So we are looking for y and what? Y. Now, to calculate the perimeter, all you need to do, you know perimeter means you add up all the boundary length. This plus this plus this plus this. That's the perimeter. So from this, you apply Pythagoras theorem. You just pick any one of these and any one of these to find your x and your y. I've almost given you the solution to find your perimeter. Then area. Don't forget that area of a triangle. There are 4 triangles here. 1, 2, 3, 4. They have base and height, base and height, base and height, base and height. Simply use half base times what? Height in 4 places and add together. It will give you the total area of this shape. Am I complicating? Then one of the 2 equal angles. Now this one, you have to suspend this until I take you through a topic called trigonometry. I will try to recall this particular question by the time I'm going to do a production on that. Because you are going to apply trigonometry ratio. So these are the 2 angles that are equal. They say you find one of them. So it requires a lot of calculation. You need to find this angle and this angle. Because these 2 make up this and add together. Then the smallest angle of the shape. This is the smallest angle, this side. So again, it is here and here. Because this line, even though it divides these diagonals into unequal parts, but the angles are divided into equal parts. The angles are divided into equal parts. So it means if I'm able to find this place, times 2 of it will give me this place. That also has to do with trigonometry ratio. Please have a look at this. With those slides I've shared on this, I expected you to make attempt on all these questions. And so please, you are encouraged to subscribe, to share, and to support. And I promise And I'll say come again for another production to fortify your understanding of the application of Pythagoras Theorem 3. So that means you should expect Pythagoras Theorem 4, real life application, because I've not even got into certain area of application at all that you need to be familiar with. Till we meet another time, do have wonderful time with your family, with your mother, with your father, with your uncle, with your in-law. Make sure that today you are nice to one of the people near you. That is how the world can become beautiful. The world cannot become beautiful if you are eating it alone. If you eat it alone, sometime one will die. So then,
Bapak lah balik ke depan sebuah sapi boy UM.
I be coming soon, but they rush me, I be down and I like making money. When you're my move, I'm getting honey. I dey call you, you dey come for me. I dey call you one day, need to pick up, I go show you shake it. This is so tight, so wet, so clean. I stop full of my G. Gang, 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 gang. We want yeah, 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 yeah. We are not saying bang, 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 bang. Check it out, till like yeah, yeah, yeah. When you're my gang, gang, gang. We want yeah, 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 yeah. We are not saying bang, 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 bang. Check it out, till like yeah, yeah, yeah. Touch my body, dance for me. Your spine brighten up the dark. Many people know me shy. I like when they call me sir. I'ma to show you back. Gang, 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 gang. We want yeah, 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 yeah. We are not saying bang, 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 bang. Check it out till like yeah, yeah, yeah. Why you